zoning, the name service is actually in the host software as opposed to being in the switch. And each host has its own idea of, of what connectivity is actually permissible.
Right. And and with Tapestry, we had a very similar solution.
And we killed it because it had administrative scalability
Because
problems.
people actually wanted, a lot of people said that they want to use switch to manage the zoning. They don't want to use host, but not everybody. In fact, there was at least one customer who asked for host-based zoning. Okay. So let's talk a little bit more about FC evolution. So the switches became, as we can see, the switches now have zoning, they have name service. They also had something called management service. But like Cisco and Diamo, they basically said, well, we're going to go one step further. So there are products like they took the whole Veritas volume manager and shoved it inside the switch. There are integrated RAID. So I mean, nowadays a fiber channel switch, there is actually a platform called, I forgot, it's called FIAS or something like that, FIAS, where the fiber channel switch is actually a complete platform of itself. You can develop applications on that platform, and kind of like Java.
So sort of a storage platform, if you will.
Yes, because
That's an interesting idea. We should look at that.
yeah, I mean, it's like the array guys, EMC, HDS want to put data services on the array. The switch guys, Brocade and MacData, wants to put data services on the switches, and of course, Sun wants to put data services on the host.
Right.
So, okay, so let's talk a little bit about migration from private loop. So, initially, back in 99, 98, when the only topology people used was private loop, and now all of a sudden this switch came into existence, and the switch was so much better and not so expensive. People started thinking about, okay, I have my SAN set up in private loop mode. How do I switch it over? How do I bring it to a fabric environment? So the first thing which came out was called TL ports. What is a TL port? A TL port is a special port on the switch. Well, it's not really a special port. It's simply a mode. So these ports, they had several modes. So you could go to the switch GUI and right-click on the port and select what mode this port is going to be in. And you can say it can be F port, which is basically a N port, a node type device with some fabric capabilities. Or it could be a L port, actually FL port, which means it has fabric kind of characteristics, but it can do private loop. Or it could be TL port. Nowadays, this terminology has changed. But so TL actually became a very big thing back in 2001. What TL stands for is translative loop. So the port will basically hide the detail that there is a switch behind it. It will simply act like so in a private loop, you had multiple devices connected in a loop. So the switch will simply act like as if it's another device connected in a loop. And it will watch for everybody else, and this is another port on the switch, and another port, there's another loop. So what the switch will do is it will watch for the traffic here, it will watch for traffic here, and it will connect this loop together, kind of like segmented loop. But it will take care of all the translations from 24-bit addresses to 8-bit addresses. Remember, in private loop, the addressing is 8-bit. In Fabric, the addressing is 24-bit. So in this case, you could have a F port here, and you could have a TL port here, and you can connect an array like we had this A5200s, which was a very famous array back in 99, 98, and we sold a lot of them. But they could only do private loop. So when switches came in, people wanted to say, okay, I have a A5200, I want to connect it to my Fabric environment. So QLogic came up with this TL concept, where you could take a device which could only understand private loop, connect it to a switch, and the switch will do the translation. The TL was actually a QLogic specific name. So Brocade had their own name. They called it Quick Loop. Both of them provided very similar functionality. Switches also had FL ports. An FL port is something which we don't really use nowadays, but it is basically the switch is saying, I am a switch, but I can also talk loop. But for that, the device has to be aware of the fact that there is a switch. But obviously, most of the initial devices did not know that there is a switch. When we say the device has to be aware of that there is a switch, the device actually has to understand 24-bit addresses. And the devices, most of the early private loop devices did not understand 24-bit addresses. Another part of FC evolution is the speed evolution. So the speeds went from 1 gig to 2 gig in around 2002, 2003 to 4 gig in 2006. And now they are going to go to 8 gig in 2008. So between 2 gig and 4 gig, there was another solution which was done, which was called 10 gig fiber channel. 10 gig fiber channel, the problem was that it was not backward compatible. So you can take a 4 gig HBA and connect it to a 1 gig device, and it will work. Connect it to a 2 gig device, it will work. But if you took a 10 gig fiber channel HBA and connected it to any of these 1 gig, 2 gig, or 4 gig devices, it would not work. So 10 gig fiber channel was basically killed as an initiator or a target technology because it was not backward compatible. But it provided a very good way to connect different switches together. So this link called the ISL, most of the recent switches now have dedicated ports which are only used for ISLs. And those ports are 10 gig. And they basically use normal cabling, but that allows the switch to talk to each other at much higher speed.
Do you get a lot of questions around the different kinds of ports on switches and misconfigured ports, or is that pretty well understood in the industry by now?
In my backline, we don't usually get that kind of stuff.
We don't get.
Not too much, really.
They'll misconfigure switches.
I'm sorry?
They'll misconfigure switches.
Sure.
A lot of times you have a U port, which is a universal port, which will negotiate whatever kind of port it needs to be.
Right. Okay.
Are most modern switches actually auto-configuring in regard to detecting what type of
Yes.
Very good question, actually. There are problems in their area. So basically what happens is the switches have something called G port or GL port, which is generic port or generic port with loop capabilities. So a generic port is basically the switch is saying that I will understand what is on the other end. If it is an N port, or if it is another switch, or if it is a device which cannot talk to the switch. And a GL port, the switch is basically saying I will enable the loop mode. I will enable the loop capabilities. But the problem is that, let's say you take one GL port and connect it to one HBA. Most of the HBAs we sell today try to auto-negotiate what the link speed is and what the link topology is. And since HBAs, the drivers and the firmware and everything has evolved from the earlier days, they try to cater for devices which do not yet understand switches. So there are still devices in the market, there are still devices which customers are using, which are a private loop only. And if you try to talk to the devices as a switch or any primitive which is not a private loop primitive, they get confused. So the HBAs, the way they work is they first try to come up as a private loop mode. And if they are able to come up as a private loop mode, then the topology becomes private loop. There's one problem with that approach is that the switch can also understand private loop, which means that if an HBA is connected directly to a switch, and HBA says I'm a private loop, switch says I'm a private loop, all of a sudden they're connected in private loop mode, which is not very desirable because which we are talking to a switch, we should be connecting it in fabric mode. But since both of them understand private loop, and both of them initially try to connect in private loop, that's what they end up with. That was the problem with some initial QLogic switches, and I think the first generation of silicon. And then somebody in the switch industry came up with this algorithm, where what they will do is they will come up in loop, and then they will look at the number of devices on the loop. If there is only one device on the other end of the loop, what the switch will do is it will again reset itself, and it will then try to come up in point-to-point mode. So the switch, now the recent switches have the intelligence of detecting what's the other end, even though the other end says I'm private loop, but it detects that the other end can talk fabric, and then it tries to come up as fabric.
So it renegotiates the arbitration
Yes.
from the switch back to the
Yes.
HBA.
Yeah, I mean, if hopefully tomorrow if I get an analyzer set up, I'll try to go through the trace. And you will see the entire 7 phases of the lip sequence. And at the very end, the switch drops the link. The link goes to NOS and comes back in point-to-point.
8 gig in prototypes in November of this year?
Yeah, so 8 gig, I think the vendors are working on the silicon, and they are saying that sometime in November, December, they will have prototypes, and early next year they will have production.
Okay.
We still have mismatches between HBAs and switches, though. Like some of the 1 gig HBAs won't work with 4 gig switches and so forth. And isn't that true?
Switch and negotiate speed down to the lowest,
Well, yeah, but does that really always work reliably?
95% of the time.
Yeah, so far I have not
Okay.
seen a problem in that area.
With older switches?
No, that's a good question. I think I have not heard of any reports where we actually had a 1 gig switch connected to 4 gig HBA and did not work. You had?
Yeah.
Okay, yeah, I mean, that's,
Sure.
I wouldn't, I'm not surprised.
Yeah.
But which switch was it?
The old Mamba, I think.
Oh, yeah.
Yeah, so it was
That,
just.
that switch had a problem connecting in 1 gig mode itself.
So, yeah, so in general, would your advice be to keep your switches up to date? Keep the switches at cutting edge technology, and then you'll minimize the difficulties with HBAs as opposed to the other way around?
Yeah, and most vendors have the latest firmware on their website, and it's not too hard to flash it. So I think that's one thing to do is to keep the latest firmware flashed. But yeah, I think 1 gig switches are way too old.
Yeah, well, it's what you end up with when you're in a software organization.
I know. We have 8 gig link speed coming up in 2007, 2008 timeframe. We have another interesting technology coming up called endpoint ID virtualization, called NPIV. So endpoint ID, so when we went to 8 gig link speed, right, people said, wait a second, this is too much bandwidth. How do I use it? And everybody is now into virtualization and VMware, and so the fiber channel folks thought about it and said, okay, we can do virtualization too. So they came up with NPIV. What NPIV does is you can actually take one HBA, one port on an HBA, and make it look like multiple ports. And today I think you can go up to 128 ports, although the spec allows, the spec has no limit actually. It's limited by the switch. So what happens is the HBA logs into the switch and says, I need another address. The switch says, here's another address. Then it can say, I need another address. So number of ports is really number of addresses the switch gives to the HBA. So it gets multiple addresses and it acts like multiple HBAs. Another very interesting concept which is coming up is PCI IO virtualization. So without going much into a lot of detail, what is becoming is that PCI is becoming like Ethernet. So like today you can you can have one Ethernet switch and you can take multiple hosts and connect it to that switch. PCI is becoming like that. So what will happen is you will actually have your devices as a separate piece of hardware which connects to a backplane, which then connects to multiple hosts. So multiple hosts can talk to the same device, and this device can say, host number this gets this virtual device. Host number this gets, actually it's a PCI function. Host number this gets this PCI function. So it basically carves up dynamically a physical device into multiple functions, and it assigns different hosts different functions.
Is that limited to PCI Express? Or?
Yes, it is limited to PCI Express today. So a single root is basically a way of taking the same hosts but dynamically converting multiple functions from a PCI device. Multi-root is basically connecting multiple hosts, multiple root nexuses to the same PCI device. So that's what a blade-based design is going to use. Another interesting technology which is coming up is FC-based T. Actually, FC-based T is probably not going to take off for another 4 or 5 years. But what it is basically is to take the same fiber channel connection but use it over standard copper cables. But the technology which is actually becoming more popular nowadays is fiber channel over Ethernet, or FCOE. And actually this C is capital. I think Star Office made it small. So FCOE is basically a way of taking a fiber channel HBA but connected to a 10 gig Ethernet. So you can actually send fiber channel frames over 10 gig Ethernet. At the same time, you use that 10 gig Ethernet for the networking. So what you do is you eliminate the HBA. You basically take your 10 gig Ethernet and use it for your TCP/IP networking. At the same time, you use it for fiber channel. So Sun has Neptune HBAs, and that's another thing which we are looking for with Neptunes. Okay, let's talk about fiber channel topologies. Topology is basically you can see it says scanned JPEG. So the topology is basically a way of how things are connected to each other. And we talked about arbitrated loop before, where things are connected in a loop. We talked about switched fabric, where things are connected directly to the switch, and the switch takes care of sending frames directly from transmit to receive, and there is no arbitration delay. There is another topology which is not very popular but still being used, is called point-to-point, or in strict fiber channel terms, it's called node-to-node or end-to-end. In this case, you just take two devices and connect them together. There is no switch, there is no loop. And the difference between this and this is that in this case, the switch provides some sort of services like name service, management service. In this case, there is no service. So if you have a switch, you can go to the switch and say, what are the devices which are connected? And you get a list of the devices. In this case, you don't have a way of getting a list for the devices. You just have to figure out, and there's a protocol that there is just one other device connected on the other end, and it's an end-to-end topology. In both this case and the fabric case, there is no arbitration delay. Those are very fast links. However, this is not very useful because you're just talking to one other device. There's not much connectivity. So now we are going a little bit deeper into the wire level detail of fiber channel, and this, it's not really, you don't really have to understand all of it, but if I thought it would be a good idea to explain these things. I want to draw an analogy between fiber channel and SCSI. So I will actually draw something here. So you use whiteboard and not use this, right?